All right, we are live now. I'm going to go ahead and mute my YouTube stream, but I'll try and watch there for questions and stuff. Let's get started. I'm Matt Lorimer, Zodiac on Discord. I've got with me today a great treat. We've got Waylon Grange, Professor Plum. He's going to talk to us a little bit about reverse engineering. Quick reminder that we do have Discord. You can ask questions there in YouTube. You can ask questions on Discord. We'll try to monitor those, watch for questions, comments, concerns, whatever. Couple other housekeeping things. SaintCon is coming this year. It will be a hybrid event. We'll do a little bit in person and a little bit virtual, try and do as best we can with hybrid. Registration should come out sometime in July. Keep looking for that. If you're not on Discord, you need to get into Discord. Go to saintcon.org and right there in resources, choose Discord. We'd love to have you join in there and help comments and stuff. We have the next couple of months of content for SaintCon Show and Tell lined up, but always looking for new ideas for content or people to volunteer to share that content. So just hit me up on Discord if you have ideas or are willing to share something. We'd love to do that. Anyway, that's all I've got. I'm going to turn it over to Professor Plum. He is, like I said, he's a genius is the only word I can think of, but he'll show us how to get some of this reverse engineering going, and yeah, buckle up. It'll blow your mind.
Thank you for the intro. I'm flattered. So yeah, I do reverse engineering as part of my day job. I did a lot more in my previous job, so I'm a little rusty at times, but I do it quite a bit. This presentation, I'm going to use Ghidra, and I have the website up where you can just download the free version of it, the public version. I typically use IDA myself, just because I have it, so why not? But I'm going to use Ghidra today. If I end up getting stuck anywhere, you might see me switch back to IDA, maybe show you a little bit of the differences. But we're going to try to do everything in Ghidra today. And I really don't have something set as in like a demo setup. What I plan to do is I'm going to just run through a real world example of a application that I recently reverse engineered and when I was looking for a particular purpose, and I'll explain that. As I go, I'm just going to kind of show how I work and what I do. But please keep in mind that because I have reverse engineered this application before, then I can kind of go through it a little quicker. When I'm actually doing reverse engineering, there's a whole lot more of what the heck is this, stumbling over something a lot longer, and like getting off in weeds and tangents. That's just, par for the course with reverse engineering. You start looking at things that you think are related, or you don't understand something and you stumble over it for quite some time. So we're going to go through something, and we're going to go through it, I don't know, in our, what do we have, 45 minutes, half hour, an hour?
How long do we have? About 45 minutes.
Okay, then we'll try to run through this in 45 minutes. If I get going too fast, or you have questions about something that I'm saying, go ahead and throw out a question there, and Zodiac will hit me up and tell me, hey, you should probably talk about this or explain what you did. And so just kind of keep me slow and keep me organized. So with that introduction out of the way, let's get started. Just a little background on what I was doing. I'm going to roll my screens a little bit. So I was reverse engineering this. .NET application, and this .NET application pairs with this IoT device. And I noticed that the application just automatically logged into the device. I didn't have to like pass it some kind of password. So I was like, okay, well, let's see what it's doing. I kind of want to see how it's doing this a lot of authentication. So .NET is, it can decompiles pretty cleanly. It's not something you typically use Ghidra for. You want to use Ghidra for something that's a C or assembly, right? So anyways, I'm reverse engineering, or I'm using ILSpy to look at this .NET application. And I basically get led to this function, which is get password for Envoy. This function is what gets this login password. And I was like, great, now I can just see how it gets this password. And so this function calls this get mobile password, passes it a serial number, a username, and some other things. So we'll go check that out. And lo and behold, this .NET function calls into a library to call this function in that library. So the .NET now drops to an assembly, and I need to go reverse this function in the assembly. And this is the point where our Ghidra comes in handy. So we're going to go take apart this lib mupw.so. So I'm going to jump back over to here. This is Ghidra. I've got it ready. I've already got the file here. So I'm just going to double click it, open it up, and we'll get started. And Ghidra threw that window in the wrong spot. So I'm going to move over here. All right. And we're just going to. All right. So it's asking me to analyze it. We'll say yes. It's going to run through all of its things it usually does. I've just got the defaults here with one exception. I've installed a plugin called FindCrypt. If you do a lot of reverse engineering and crypto's involved, this is awesome. What FindCrypt does is it will look over the assembly and notice any constants that belong to like an MD5 or a SHA-1 or any kind of hard-coded like AES S blocks. All of those it will notice and mark them for you. So if you see a function that references them, you'll easily identify that crypto that function is trying to perform. So that's the only addition that I have added here. I'm going to let that analyze this, and we'll go full screen. And so just a quick overview here as we talk about this. The center console that you see right here is the disassembly of the file. This is taking all the the machine code and turning it into disassembly or data wherever the Ghidra sees fit. On the right side, this is the decompiler, which is really quite cool. It will try to take the assembly functions and turn that back into C code. And so that's really helpful. But as I get going, we'll see this more often. The decompiler is not a one-to-one, right? Like it tries its best to come up with pseudocode that matches the assembly, but that's not always possible and it's not always accurate. And
I was
sometimes
going to say, how accurate is that? So when it does create it, is it like usually about 80%, or is it?
Yeah, that's good. That's what I would say, 80%. It's pretty good. We'll see some spots where it's not quite right, or at least it thinks it's right, but it's pretty close. If you're seeing something that's just not making any sense, I would go back and verify that's actually what it's doing in assembly, which is painful, but it really helps you, because I've been beating my head. I was like, why are they doing this? That makes no sense. And then I look at the assembly, and they weren't doing that at all. That explains it. So we'll see some of that, and I'll talk more about it as we get going. Maybe we'll talk about that first. And then over here on the left, this is the sections in in this case we're talking about an ELF file, so it's not a PE, but these are the segments in the ELF file. These are the functions that it recognizes. So there are some that are exported. Here's a number of functions in here. All these ones with name fun, whatever, these are not exported functions, and the function name has been stripped from the binary. So it's just generating a name based on where it found it. So fun, 1070 was found at address 1070, and it just knows there's a function there based on the disassembly, but it doesn't know what that function name was. And so these are all the functions. It has signatures for very common functions. And with my FindCrypt, you notice here it was able to recognize this MD5 init, this MD5 final, and MD5 update, which will come in very handy for us. So it automatically has signatures for some very common functions like stir length and print length and whatever. But like we said, we want to go check the exported functions, and we wanted to find emu get mobile password. That's the function that I was really interested in. I'm going to try to ignore the rest of the binary as best as I can and only get involved in anything else when it is referenced by this or needed by this function. So when I clicked on that, it highlighted the disassembly for that function. So you can see here's the disassembly for get mobile password. And then over here is what the decompile, or what it assumes is the decompile for mobile password or get mobile password. It's not very wise to the parameters coming in. It just knows, I think this is an int, I think this is an int, a char star, a void star. But if we look back at where this is being called, we know that the first parameter is a string, and it's the serial number. The second parameter is a string, which is the user, the string, domain. This is a string, an output buffer, and then an int, which is the buffer length. So knowing that, I'm going to go back and decorate my function with that information. As much as I can do to help give me more context as I'm working, it's going to be more beneficial to me. So I'm just going to right click on this, and I'm going to say edit function signature. And that's what we want to edit up here. Let's see. That's not how I wanted to edit it. How come you're not letting me touch things? That's really weird. Probably because I'm in full screen and it's really freaking out about it. Yeah, I can't click on anything. Did Ghidra just give me a hard time?
It's mad because you had mentioned Ida at the beginning of the call.
I did. I offended it, didn't I? I can't really click on anything. Now it's disappointing. All right, what am I going to do to get that guy to work with me here? Let's see. Oh, I didn't even click on that. Go away. I might just have to kill Ghidra and start again. That'll be okay. Won't be too bad. Sorry, guys. Ghidra still has quite a few bugs, the public version at least, and it's still growing, I'd say. Start back up from the beginning here. I'm not going to full screen it. I actually think that's what was breaking me. I've never actually run it full screen before. All right, so it's opening the binary again. We reanalyze it because I didn't save. And export, skip mobile password. We're going to go edit function signature. This seems a little, there we go. Okay, so we know that the first thing in is a char star, which is the serial number. Second parameter is a char star, not an int, and that's the username. Third one is the domain. Fourth one is the out buff. And this is the out size. So doing that, once I update that, that actually is going to go through the disassembly and change the types where those types are being referenced. So it kind of helps me get the type of variables that it's using more accurately. So as we go through this, I want to talk about a few things. First off, when I click on something in this decompile window, it's going to show me that exact matching assembly. So if I've got something here like this ZX816, I'm like, what the heck does that mean? It's showing me, it'll show me the assembly that matches that right here. And what this is really doing is that's just zeroing out this memory. So it's more of a, it's like a memset 0, but instead of calling memset, it's like the compiler decided, oh, it's faster if I just zero these 4 variables out myself rather than call memset. And so the compiler just made this zero out this whole area in this format. And that's what I like about Ghidra here is you've got the 2 windows side by side. So like if there's an instruction that's like, what the heck is this doing? Or where did you get this? Then it can show me where it got that from in the assembly, and I can verify that it did decompile that correctly. So that's a little help there. So I'm gonna start working through this. We're gonna start from the top to the bottom, but I may jump around a little bit. So these are all up here. This whole section here are, if you're familiar with C, right? These are predefined variables. But in disassembly, you don't get that context at all. All you get is there is X space on the stack for variables. So as Ghidra decompiles, it tries to build these variables and guesses their names and sizes based on how they're referenced. Kind of like based, like, oh, he did a memset for this much space, then that I'm going to assume that's a character pointer of that much size. Kind of uses cues like that to determine things. But these are almost always incorrect in some form or another. It's a best guess, and you really can't rely on these to give you much context. So we'll even kind of, so we're going to go. This first one is really funky in GS offset, whatever. I'm just going to explain this one to you because you can basically walk over this, but what this is doing is this is your stack canary, right? Like you get in a function, it sets a stack canary, and then when you leave the function, it checks the stack canary to make sure the stack hasn't been broken. And so sure enough, like you see it set a value here, that's the stack canary, and then at the very bottom of the function, it checks that variable to make sure that it's still the same value. And if it's not, then we do a, hey, you failed. So that's just what that is. We don't really need that. This boilerplate code that the compiler throws in. So we'll just kind of ignore that. So from there on out, we see they're setting some kind of buffer to 0. And this total size of this buffer is 4 16-byte things. So that's 64 bytes that it's setting to 0. And it's also setting the output to 0 initially. That makes sense. It saves the serial number to this field. Okay, that's something to hold on to, whatever. Those are all just kind of like initialization stuff. Nothing. I'm going to make it a little wider. With the font so big, it's kind of hard to see. Okay, this one too. Wow, I'm running out of time faster than I thought I would be. Okay, so and then we'll move down from there. So we're doing it. If the serial number is not null and the username is not null, then it sets this variable equal to in-phase energy. Okay. And then if the domain is not null, then it sets that variable to the domain that's passed in. So basically this is I'm going to rename this right here. We're going to call this the local domain field. And basically it has a default domain as inphaseenergy.com. But if the user passed one in, then we're going to use the user supplied one. But if not, we'll use the default. That's basically what this little if right there is doing. And then we do a printf. So it's building a string, 3 pieces here. So I'm going to call this, let's call this just the temp string, because that's where it's outputting. And so snprintf says the string's being built via something at something hash something, where it's username, local domain, serial number. So if I'm just going to kind of follow along, actually, I don't think I have time for that. So I don't think I'll do that. So just kind of keep this in mind. Temp string is now a string being built with a combination of the username at domain hashtag serial number. And then they zero out another, let's see, this is zero out the same field actually. I'm not sure why they zero out twice, but whatever. They zero it out twice. And then we call this function here. Oh, okay. Let's go figure out, looks like we have to do a tangent now to go figure out what this function is doing. So we'll call that function. We'll jump into there. Huge stack stuff, but as we get down in here, our find crypt is really helping us tell what it's doing. We're knitting an MD5, so I'm going to rename this as my MD5 context. And then it says if parameter 2 byte 9, don't even know why it's checking that one. We'll come back to that later maybe. But if it's 0, then it starts to build a local variable here. And what does this hex look like? Anybody recognize some of those hex offsets? They're in the ASCII table. So if I go over to the ASCII table, right, hex 5D, 65, 5B are a bracket, 65 is an E, and what was the other one? 5B, which is another bracket. So really, this is a string. Now, Ghidra, this is one thing I dislike about Ghidra. I'd love to be able to tell Ghidra, hey, that's ASCII characters, not a number. It's not that smart for some reason. I can only do that over on the assembly side. On the assembly side, I can say, yo, this is ASCII. But over here, in the decompile, it's like, oh, did you mean a number? So now it just changed it from hex to decimal. But we know that's a string. We know that it's these bracket E bracket. So it's got that 3-character string called string length on it. That's variable 2. And then it passes them both to MD5 update. So it starts as MD5 hash of just those 3 characters that it assigned. And then it gets the string length of parameter 3, which I should have labeled this. That was the input to this function. That was the string that it built in that other function. So I'm going to call this the supplied string. Sorry if this is kind of confusing. There's a lot the variables to keep track of in your head as we're doing reverse engineering. So it takes that supplied string, adds that to the MD5 update, and then it's got these funky variables, which again, they're all in the ASCII character range. So I'm gonna go over here and just tell them, hey, these are characters, help me out. It doesn't look like it's helping me out very much. It looks like it's still just turning them into numbers over here. Maybe if I refresh, no. All right, well, you can see that these are a bunch of letters and they're in 4-byte chunks. It's actually a string, but it's treating them like an int. And so it's just putting 4 bytes of that string in at a time. I wish it was easier to see. Maybe I can show you in my IDA view. Let's see, I'm just gonna show you IDA real quick. And let's see what that does. So this is that function. Bear with me, we get there. So see, IDA does a very good job of determining what's really going on. IDA says, yeah, it's building a string, and that string is in phase energy. So this is kind of side-by-side differences here. Like this is IDA trying to tell me what's going on there. And it's very clear that, hey, I've got this, bracket E is passing that to MD5 update, taking the string length of the variable passed in, passing that to MD5 update, doing a string copy on this funky in-phase energy string, and then that's passing that to the update, and then finalizing the MD5.
So do you find that the C in IDA is more accurate than the C in Ghidra?
Much more accurate. And that's what you pay, what, $3,000 for the, so IDA itself is like a named license, I think it's like $1,000. And then if you want the decompiler, the part that turns this into C, then you pay a $3,000 cost on top of that. And you only get one processor. So you're like, I want you to be able to decompile x86. Well, that's $3,000. Well, I want you to decompile ARM too. Well, that's another $3,000. What about ARM64?
ARM, like ARM v7 and ARM v, like all the different versions, all the ARM family.
Just so it'll do ARM32 as one family and ARM64 as another family. So the 4 common ones are x86, x64, ARM, and ARM64. So that each one of those is $3,000 a pop, right? So you're talking $12,000 plus another $1,000 for just the base IDA license. And that's per year. It is crazy expensive. But as you can see here, it does a pretty good job of making sense out of the mess, right? Like this is very clear. It's very easy. It's almost straight C code there. Whereas what we're looking at in Ghidra here, it's just a bunch of numbers, and it's slightly there. So yeah, there's definitely benefits, but you're going to pay out the nose for it. So if I was to kind of review what we've got here, I'm going to jump over to Python. It's basically, it's going to do an MD5 hash. So I'm going to pull in hash lib. And it's building a string, which is based, let's see, let's just call it that. It's basically, it starts with the E, whatever, plus username, plus at the domain, which the default domain was energy.com, hashtag the serial number. And it basically just did an MD5 of that, right? That's what we were watching it do. And then we'll continue from there. But oh wait, and I forgot, it had that funky string it appended to the end. Okay, so it computes an MD5 of that crazy string. And in my app, we actually saw the username was installer. So I know most of these. I just need, a serial number of said device. And so far I can kind of stub out what this function is doing. So let's go back to this. Calls MD5 update. This is that funky string. We're going to skip this else clause and just go down here. MD5 update. So what is it adding? Local 95, local 98. Local 98 is that string. So we're just kind of that's a string, finalize it. And finalize is going to fill out this buffer with the hex value. So this is the Now I've got this digest, and this function right here, I'm not going to talk about it, but if you notice, this is a good indication of what it's doing, and it's walking over the MD5 digest right here. Basically taking turning it into hex, right? So how I see this is so it's a do loop. Now when you write code, when it compiles, a do while and a for loop are essentially the same thing, and so every for loop actually turns into a do loop. This is do while variable B5, and B5 is just Boolean saying as long as var3 is less than 15, right? That's of a hash. So it's basically for I to be equal 0 while I is less than the length of MD5 hash plus I. That's right here. That's your for loop logic. Go on. And loop is just one as its value from MD5 digest at I. I'm not sure why it says I minus 1. Actually, I bet you we can explain this, but I'm running out of time, so I won't. So this is basically just taking the hex digest from MD5 and making it, or the digest, the binary digest from MD5 and making it a hex value. So we can do that here. We can just say hex digest. Yeah. Horrible naming my variables, but that's about all this function does. So I'm just going to rename this function so I now know that this function is get MD5 hash. I don't like that. That's not a capital. Okay, so now let's just go back to our other. It's not taking me back, so I'm just going to click here. There we go. Now we go back to our function, our mobile password function, and it should update that now instead of fun whatever, it says, hey, here's MD5 hash, where it passed in our temp string, and it gives us back our hash, and which I should have paid more attention to it. I bet this is our local hash, but let's make sure. Yeah, so I'm going to call this is the MD5 hash hex. That's the name of that variable. And this is the hash length. Okay, so now it's going to do an if the hash length is at least 15, the hash length of an MD5 16. So basically saying if the hash worked, then we're going to do this stuff. And it sets this variable to hash length +1, which is really kind of weird. But this is just whatever. We'll call that a variable that sets to hash length +1, initializes these ones to 0, and then you see a do while. So I'm going to assume this do while is probably a for loop. And if you look at the bottom, so it's do while var1 is greater than 1, and var1 is this. So this is basically our I, but it's counting down. You'll see here var I plus -1. So this is a for loop counting down from hash length. And then it also has a second variable that is counting up as we go through from 0, that'll go up to 15 as it goes through this loop. So what this for loop is going to be doing then is it looks like it reads from the MD5 hash, I variable -2. And this is really kind of funky. I want to show you something. Let's see here. How can I show you this? Oh, look at this, actually. So this is actually a little smarter. I just did this. This is the first time I've done it in the updated version of Ghidra. The version of Ghidra I was using before this did this a little differently. And what it did is it didn't show MD5 hash here. It showed this variable local E4 here. but it didn't have this -2. The offsets were right. This one, the offsets are not quite right, but the addresses are the same. So this is a problem with the decompiler. They're really just accessing the last element and counting backwards. I mean, this still would work just fine, but this whole +1 and -2, they kind of cancel each other out. This is really just start at the hash length -1, which is the last character, and start counting down. What I wanted to show you isn't there in this version. So this looks like they fixed the bug. But anyways, they take that character. So we're just going to take, this is one of the hex chars from the hash. And they say, okay, what is Ivar? Ivar is something else that they're not using. So if Ivar starts out to 0, if that's less than 8, then set the out buff plus Ivar to the hex character. Okay, and we see, oh, Ivar, looks like it changes. Ivar is iterated when the loop's counting down. So for the last 8, it's counting backwards to the hex, and the first 8 characters that it counters, it copies over to the out buff. So it looks like it's taking the last 8 characters of the MD5 hash in reverse order, and maybe that's our output, at least initially. If it was to say return right here, then that's what all I would need to do, is I would basically go back over to here and say something like, my password is the last 5 characters, or the last 8, excuse me, I don't know where I got 8 from. So first off, reverse the order because it's counting backwards, and just give me the 8 characters. And maybe that's my password, so as I'm following along. But it's also doing some other things, so it's not that easy. So if the character is the digit 1, then increment this guy. So apparently this is counting the numbers of ones. This is the count of ones. And then here, if the character is a 0, then increment this. So we've got also a count of zeros. Okay. And then these are just my 2 iterators, the one that's counting up and the one that's counting down. So that's basically what this is doing, is it's walking the hex output backwards and keeping a count of the 1s and 0s. And then it also saved the last 8 characters to this out buff. Kind of funky. My initial guess, if I just had to guess, this is probably used for some kind of CRC. It's not, but that would be what I would have thought it would have been doing. So after that for loop completes, then we have another one. This is another loop. This is while Ivar does not equal 8, and it resets Ivar to 0 here. So this is probably another, this is our counter, because there it is there, getting counted up. So this is another for loop, this time while it's less than, well, it does not equal 8, right? So I could make in my code here for I in range 8. Okay, we're going to do something. And what does it do? Okay, first thing it does, if the count of zeros is less than 10, and it does this bit comparison with the count of zeros. This is kind of funky. We may have to break this out just a little bit. I'm going to copy this over. I know I'm running out of time, guys.
Don't stress too much on time. If we go a little bit, it should be fine.
Okay.
Real quick question while you're doing this.
Yes.
Do you often write Python code as you decompile this, just so that you can remember it later, or is this just something for the demo?
No. So the things I used to do. In this case, I wanted to be able to figure out what it's doing to generate the password, so I could generate the passwords myself. If I wanted to do that, then yes, when I ran through this, I wrote the Python code as I was going through there. If I don't think I'm actually going to write the code and I'm just trying to understand what it's doing, I'll typically put comments in next to the function. So I may put a comment in right here saying this is doing XYZ, or for loop 1 to 8, to kind of give me the context so I don't have to keep it in my head. But so I do both. Okay, this number right here, I'm going to break it out into its binary real quick. So a 2 is 0010, a 4 is 0100, and then an 8 is 0 or a 1000. So this is what that pattern is. And if I go back to the Ghidra, it's saying it'll take the count of zeros No, that's not what it's doing, actually. Where is, well, you little, okay, this changed things on me, but this still makes sense. I'm trying to see this, the code that match. I want the code that matches that right there. That is not the code. So it's like highlighting this one line, and this is another discrepancy with me. It is not doing a BT branch there. It should be jump 0. Where is it? All right, that's a logical shift right, and that's not even in the code. Okay, going back to IDA because I think this guy's lying to me. Where's that function? We're looking for where it does this do loop with that variable. That's where it is. I'm even going to go to the source code. Arrgh. This is taking long. You don't realize how fast time goes when I'm going through things. Okay. Anyways.
I really like that formatting of the code over there in IDA as you were.
Oh, yeah.
Even go back to the assembly. Like that's.
This is assembly, but it's the nice logic tree, right? Like you can see how loop. This right here is a good loop. Oh, you can't see my finger. This right here is a good loop. Visualization. Okay, right here. This is the one. What's really going on here is it'll take the count of zeros and it will shift one left that many spots and see if it equals this. It's the same logic if you shifted this number right by the count of zeros and then checked if that digit's 1. So basically what we're doing with this string, right, this set of bytes, it'll shift it right how many count of zeros there were. So if there was 3 zeros, it'll shift it right 3 times and check this bit. And it says, if that bit is 1, then do something. If that bit is 0, then don't do something. So what we can gather from this is if the count of zeros is 3, 6, or 9, it does something. And what does it do is it decrements the count of zeros. So if the count of zeros is 3, 6, or 9, it subtracts 1. Kind of funky. We'll get back to that. I'll make sure to get back to that before we run out of time. And then it does something similar with the count of ones. If the count of ones is 15 or the count of ones of 9 is 9, subtract 1 from the count of ones. Okay, well, I'm not going to copy that over to Python because I'm running out of time. And I'm just going to kind of talk a little faster right here. This is a clamp function right here. If the count of zeros is not 0, it's less than 0, min is 0. If the count of zeros is greater than 20, make it 20. Same thing right here. If the clamp the number of ones to between 0 and 26. And then down here, get the character from the outbuff that we've already saved. And so count of 0. If that character is a 0 in the outbuff, then grab, so count of zeros minus 1. This is again an error. Basically, grab the count of zeros plus the offset of the letter F. So what it's doing is it'll say, let's say there was 8 zeros in the original function, then it'll go from 8 and count 1, 2, 3, 4, 5, 6, 7, 8. And it'll insert an N instead of an O. So it's replacing the 0 with an N. Now, this is the interesting part. Remember we said it's going to skip 3, 6, and 9? Guess what characters 3, 6, and 9 are from F? 1, 2, 3 is an I, 4, 5, 6 is an L, and 7, 8, and 9 is an O. Any reason you can see why it's skipping those ones? Yeah.
We don't care about character ambiguity.
Character ambiguity. Yes, it's starting to make some sense now. They're replacing zeros and O's with characters that are easier, but they didn't want to replace O as a 1 with an L, right? So they skip those. So that's what they're doing here. Character engineering, we now know how to generate the password for any one of those devices.
Does this have anything to do with an RSA presentation?
This has a lot to do with an RSA presentation. Next week, no, 2 weeks from now, I am speaking at RSA about solar panel controllers and their vulnerabilities. And this is material coming straight from that talk. I won't be going over reverse engineering in the talk, but I will talk about this vulnerability and others. So totally applicable work. I mean, this is not one of these like just made up use cases. This is a real vulnerability. I don't know if this one got a CVE, but some of the others got a CVE that were very similar to this. So yeah, that's RE and work and breaking things, right?
Yeah, this
Um,
is super cool.
yeah, I think it's super cool. I think it's the awesomest job. It's really cool stuff. I know it's kind of confusing to talk through. I know when I work, I keep track of a lot of these variables in my head. I could write them down on sticky notes or something, but my context and my understanding of the variables changes so fast or as you're going through here, like, oh, no, that's what that means, that my notes would just be a lot of crossed out lines. So I just try to keep track of it all in my head. I'm trying to see what else is in here that I could show you. Some of the things were bugs they actually fixed in this version of Ghidra. So I'm pretty excited to see the improvements. I know soon enough. I'm surprised. I'm surprised I can't label hex values as strings yet. I'm sure that bug will get fixed soon. That where I could say, hey, this is a string. You should figure that out. But
Yeah. So couple questions that I've as you've been going through this, I've thought about is, I've seen this a couple times and I've been to workshops and it still feels a little bit like a fire hose. What tools would you recommend or what sources would you recommend for someone who is new to this to dip their toes in and start to get used to it? I mean, there is some level of you just need to jump in with both feet, but what
yeah.
are some entry level challenges or tools or walkthroughs or classes that you would say
So
are
here
helpful?
few things I recommend. So tools wise, Ghidra, grab Ghidra. Another one, if you're not, Ghidra's great for assembly. If you're looking at .NET applications, I really love IL Spy. It gives you it gives you really good .NET reversing to C#. And then what I'd recommend you do with the tools though, is that you write your own program and then decompile it because you know what that program's supposed to be doing. But when you see what it turns into, then it's a good mediary step, right? You're like, I know what this is supposed to be doing, so I can kind of already have some context. But matching that up to what I wrote is because what disassembly it's going to come up with is not going to look like your C code you put in. So that's what I would totally recommend doing. Um,
That's a really
I,
cool idea. I've never done that, but that makes a ton of sense.
yeah, I actually have done that recently for myself when I was looking at an embedded processor, right? Like a stem processor or even like an Arduino. If you write an Arduino app and then grab that binary the hex before it copies it over to the target, I mean, it saves it to disk, and then load that in Ghidra, you'll see like the Arduino framework adds all these boilerplate functions and all these other calls, and it's just this mess of code. And you've got this one little function is the function, your main loop, but all this other code's in there that makes it really complicated. But once you've done that, then okay, I know to ignore all this boilerplate and to look here for the main stuff. So on the actual target, then I could skip the boilerplate and jump to the main stuff. So I do that all the time. I actually use IDA, especially right now. As I'm not doing malware analysis as much as I used to, my main use for IDA, besides vulnerability research, is to look at my own tools and things to make sure that they're doing what I expect them to do, or to understand what that actually turned into in code. What's that look like to an attacker or a defender? So yeah.
That's cool. Any other hints, tips, or suggestions on where to go, what to look at, things to do?
Yeah. So after you've done that and you kind of feel you're comfortable with things, there's a challenge that FireEye puts out every year called the Flare-On Challenge, which it's a number of reverse engineering puzzles that get greater difficulty as they go up. And they're not all disassembly challenges. Some will be .NET, some will be JavaScript, some will be, I mean, they're basically challenges that are based off of what type of malware and threats they've seen in the wild, but they're good challenges for their RE guys. I know it used to be used as a hiring pool, but now it's just kind of it's a fun challenge. They give out a reward. It used to be like a challenge coin in past years. One year was like a solid belt buckle. Like they give out cool things if you can get all the way through it. They are hard challenges by the end. The first few start out pretty easy, but the last ones, like it took a good 2 or 3 weeks to get the last puzzle every year. They get pretty challenging, but it's kind of fun. It gives you a kind of a gauge, and they always post the answers afterwards, or at least they let others give their write-ups. So that's one that really test and hone your reverse engineering skills. If you feel like you're up for it, that's a good one to do.
I'm going to throw another one out there, and this is the B-sides badge the last couple of years that you've made. I remember the one you made, was it 2 or 3 years ago, where you had the canary in there, and that was the first time that canaries really clicked in my head. You've done some amazing things with this front too that are educational tools. If you can get your hands on a B-side Salt Lake City badge, one of the ones that have been made by Professor Plum here, it walks you through this in a way that mere mortals can understand and make sense of it. And all of a sudden, the concepts will click in your head, and it's really cool.
Thanks. And I put a plug out for the Hackers Challenge at SaintCon too. We usually have a few reverse engineering puzzles in those Hacker Challenges there that are good to test your skills as well.
Agreed. Well, thanks again. I really appreciate you taking the time to go through this. This was really cool. And then to hear that it's that solar controller just makes it that much cooler, knowing a little bit more of that backstory. And look forward to hearing more about that as it comes out, as you get that presentation out there. But yeah, this has been really fun. It's been good to learn. If anyone's like me and this feels a little bit like a fire hose, it is something that you can do. It just takes time. It takes patience. It takes familiarity. Like I said, maybe 1,000 sticky notes to write variables on. But like anything, start small, start where you can, and chip away at it, and your skills will grow. And it's a really powerful thing to do, and you can get some awesome stuff. You can learn some cool things, and really get into the mentality, whether you're on a red team or a blue team, really plays out on both sides of that, and gives definite value to your job to understand a little bit about this. So thanks again for taking time to do this. Appreciate it. You sharing some of your wisdom with us. Yeah,
of course. Thank you guys. If you've got questions after the fact, feel free to hit me up on Twitter or Slack, or I guess Discord, not Slack. So yeah, I'll be around. Thanks, guys.
All right. Thanks, everybody. We'll see you.